the last part of doing every challenge question in regular A-level maths pure books is book 2, review chapter 3. Let's just do it. To differentiate this, it's going to be every time we differentiate y, we're just going to tag on a dy over dx. And every time we differentiate x, we're just going to do it normally. So this could be a dy over dx plus 2x. This is some product rule, so differentiate the x first, just to get a 1, and you get 4y. And then differentiate the y to get a dy over dx, and it's 4x dy over dx. Equals 2y dy over dx. Good, so that's all done. Going to group all the dy by dx's over onto the right and factorize out everything that's multiplying by them, and then divide. And of course, to make dy by dx 0, I need this thing to be 0, just the numerator, which will give me that, which of course gives me this here. So okay, that's when dy by dx is 0. Let's substitute that x value into the original curve to find the coordinates of when it happens. So okay, we get y as this, which leads to this, which leads to this. And then you can say either y has to be 0 or y has to equal a over 5. Of course, we can go back in here to finally find the x coordinates. If y is 0, x has to be 0. If y is over 5, x is minus 2a over 5. And so we end up with our two coordinates here. Given a isn't 0, show that this is never true. So, okay, well, dx by dy is just this flipped over, so we'll flip it over. And for that to be 0, we need this to be 0 as the same as was before. Okay, well, we can rearrange that. I decided to do this for y. I'm not really sure why I did that. I just did. So, okay, well, if I halve that, I get this and put that into there. And then x squared stays the same. And then this y just goes in here. This is 2x times 2y, I pretended, which allowed me to do it without fractions. And then, of course, divide by 2 and square everything to get this. I times everything by 4 at this point, which made everything that I'd done previously pretty pointless, but that's okay. Rearrange, obviously, to make it in some kind of quadratic, you get this. And then just test b squared minus 4ac. When you do that, of course, this a refers to the number in front of x squared, not these a's, but we all know that. We get this when we do that, which is less than 0, except if a was 0, but a isn't 0. So that's always less than 0, so there are no solutions here. And so there are no points where x by dy equals 0. And that is that done. Next question is very similar to something we did in a previous chapter, where we've just got to find the area between these curves. So let's find the intersections first by setting this equal to that. Of course, cos 2x is cos squared minus sine squared. That's the only one I actually memorize. Because from here I can just say cos squared is 1 minus sine squared. And so this is 1 minus 2 sine squared. Rearrange. Of course, the 2's vanished when I took away 2 from both sides. Get a quadratic, factorize it. You have solutions at sine x equals a half or sine x equals minus 1. Sine x equals a half is pi over 6 or 5 pi over 6 or so on. I'm not going to go any further because I'm only looking for 3 solutions. So I think I'm going to get 2 from here and then the first one from here, which is 3 pi over 2. And then, of course, I'm just going to integrate. Now, just be careful here. This curve is on top for the first bit until pi over 6. So that's going to be this curve minus this curve for this area between 0 and pi over 6. Then in this area, we're between pi over 6 and 5 pi over 6. And this curve is on top. That's going to be this one minus this one in there. And then finally, we're going to add on the integral between 5 pi over 6 and 3 pi over 2. Again, with this curve on top and then this one on bottom. All the 2's cancel immediately, which is nice. And so we end up, and of course we can do the integral, so cos always integrates straight to sine. You halve it if you got a 2 here, of course. Sine integrates to minus cos. Just be super careful to get these integrals correct. And then be even more super careful to substitute all of these values in correctly, which I think looks like this. It's really good practice to think about these substitutions and see if you can do them without a calculator. Because, yeah, it's just good practice if you're ever taking a university entrance exam. Anyway, all of that simplifies. I just counted, essentially, the root 3's. This is, of course, 2 root 3 over 4. So there's 1, 2, 3, 4, 5, 6, 7, 8, because you're adding 9, 10, 11, 12. 12 over 4 is 3, so it's 3 root 3. And then you got this random minus 1 left over here as well. And that's every challenge question done for book 1 and book 2. Moving on to the next book shortly.